All right, it's 2:02. Let's get started. So, hello everyone. Welcome to Ask Seminar series. This is our last virtual seminar this spring. And next week we will have an in-person seminar. And I hope you will be there. And let's finish strong. And a little bit housekeeping. So, this seminar is being recorded. And we will post the recording on our YouTube channel. And after the presentation, we'll have a Q&A session. So please feel free to bring up any question you may have. And usually our director, not speaker, join us and will introduce the speaker. But he is unfortunately occupied today. I think that's pretty much what I have. I'm going to hand the ball over to Kathy, our communications specialist. And Kathy, please introduce the speaker and
Thanks, John. So I'm excited to introduce our speaker today, Dr. Twila A. Moon. She is a deputy lead scientist at the National Snow and Ice Data Center within the University of Colorado Boulder's Cooperative Institute for Research in Environmental Sciences, who is a global leader in earth science. In 2025, Dr. Moon also became the first climate science engagement lead at the CIRES Center for Education Engagement and Evaluation and launched Engage Climate Science to ensure insights escape academia. Dr. Moon is a world-renowned glaciologist specializing in the connections across ice, climate, ocean, ecosystem, and society, and bringing climate science knowledge to decision makers and business leaders. Her pioneering research focuses on Greenland and the Arctic and has been published in high-impact journals and received global media coverage. Dr. Moon has also testified for the U.S. Congress, serves on the U.S. Polar Research Board, and is the lead editor for the Arctic Report Card, which is NOAA's highest impact annual report. And she's also a fellow of the Explorers Club. In 2025, she was awarded the AGU Pavel S. Malkhanov Climate Communications Prize. So I'm just going to go ahead and hand it off to Dr. Moon. Thank you for joining us today.
Thanks so much, Kazi. Let me get my window sharing started up here and see. I think I can see a few of you and sort of keep an eye on my chat here if I arrange things in a reasonable way for myself. Um, Super. Great. Thanks so much for the invitation and thanks for those attending. I can already see there's going to be some fun shout outs during this seminar today, which I'm looking forward to. And I think you can see my slides and my mouse if I'll point around to a few things. So I'm going to chat today about QGreenland, which is kind of a project that is expanded in pieces. I'll tell you all about it. We'll talk about sort of this integrated geospatial information system framework that we've built over time and in partnership. I'm Twila Moon. I'm highlighting here on this slide some of the folks in that next line from the University of Colorado, Trey Stafford, also not here, Matt Fisher, where some our first developers. Robin Marowitz is the developer now. Mariama leads education and outreach. I'll talk first kind of mostly about QGreenland. Don't worry if this doesn't quite make sense. It will as we go along. And then I'll talk about QGreenland Net. And that's work that also includes the Arctic Data Center. Matt Jones is leading that. And we have different people, Rushi Raj, Ian, and Angie over there. But I put some plus signs at the end of this. So QGreenland is a project that really started in 2019, and that means it has included a lot of really important contributors. I saw Vinton Valentine here in the attendees. He is our board chair for our coordinating board that advises the QGreenland project. He previously served on the editorial board. So QGreenland was supported under the National Science Foundation's EarthCube program and in our first grant, and currently we're supported by the National Science Foundation under the Geosciences Open Science Ecosystem program. And I just got back from a PI meeting in DC for the GeoOC program. So we were all together on Thursday and Friday. So I added in a couple little kind of challenges, discussion opportunity points at the ends of these slides that in part were informed by discussion from that meeting. So if in our Q&A time, you also just want to chat open science ecosystem, no worries. All right. So first, let's get up here and move some slides. What is QGreenland? So QGreenland, if you haven't explored it, it's a curated interdisciplinary data package. So we have dozens of data layers. They've all already been undertaken any kind of transformations needed so that they're going to work well together, so that you're downloading this as an all-in-one Greenland-focused GIS data package. That way it works offline for those things that you've downloaded. It also works online, and I'll mention a little bit about that. And it's a package that works on the QGIS software, which is free open source software. It's sort of the open source competitor to an ArcGIS. This is what it looks like if you're opening up your QGIS environment. You have data layers to explore on the left. You have a mapping environment on the right. And I'll talk a little bit more in a moment about kind of why QGIS. But first, a little bit more on QGreenland. So those data layers are organized by theme. This is sort of a look into the file folder that you get as you download things. And you can get a sense that there are going to be data sets on everything from geology to base maps to sea ice, to some projections from future ice sheet models and some kind of averages from regional climate models. QGreenland is not designed as to already have all the data you need for your research. It's really designed as a place that you can get started from for research and education. It also covers fairly wide boundaries. So there's both a kind of data that is clipped to a more Greenland specific boundary, and there are also data sets that are going to cover the entire Arctic region. So it can be used to cover a wider area than Greenland if that's of interest to you. And as I hinted at, there are data layers that you download locally and then you can use offline. But there are also some data layers that serve really high resolution data, or they are capable of serving, for example, near real-time data that require internet access. But the beauty of using something like this is that those things can coexist together in your workspace, and you can be mindful of what you have available locally, offline, or what you need to link to elsewhere, because it's maybe very high resolution data, something along these lines that's really hard to manage locally. Why QGreenland? Well, this is a very fun shout out specific to this, as I saw George Roth also in the attendance. And so I want to give a shout out that QGreenland would not happen at all without George Roth, actually, who was part of the team working on Quantarctica, an Antarctic QGIS data package that really served the geoscience community. And glaciologists and others who were working on the Antarctic ice sheet said, we would really love this to exist for Greenland. The Norwegian Polar Institute, who hosts Quantarctica, said, we won't be doing that. George Roth took to the streets, so to speak, to find a group that would be interested in the development of QGreenland. And so really it was researchers, myself included, being a person who wanted this to exist, wanting this to happen. And then we've undertaken some additional emphasis on open science approach in our development of QGreenland, as compared to, for example, our inspiration from Quantarctica. And I would like to point out too that George Roth designed this logo, which is fantastic and we continue to love. So a brief side note here on open science, to just get your brains thinking in that sort of space and remembering that there is a whole spectrum. There's open science is not black and white. It doesn't apply to just one of the areas that we do work. But as we're thinking in Q Greenland about trying to support open science ecosystem, some of those things there on the far right, we want to think about free and unlimited access, about good documentation, about linking data and publications, making sure people know about provenance, about where things have come from, making sure that things are transparent. People can interact and see the steps or the development that goes into them, making things reproducible. In our case, this all means that Q Greenland is fully developed in GitHub. You can follow along, you can interact with the development. When you build a Q Greenland data package, all of that happens as a machine build. All of the things that happen to the data are fully recorded, so there's a sense of provenance, and you can see what's happening, and you could reproduce the build of a Q Greenland data package as well. And this teaching culture, kind of trying to really help others be able to work well and be interactive, is a really, I think, important part of open science. And we have seen a really important part to disseminating and helping people get on board with using Q Greenland. Another really handy or kind of timely item related to why Q Greenland is the first Greenland National Research Strategy, which actually came out after Q Greenland was begun. But this is Greenland's, as I said, first national research strategy. And one of the primary tenets within it is that research results must be accessible to all. So we hope that the work that Q Greenland is undertaking is helping to make Greenland-focused data more findable and usable. And also things that we're doing can support other Greenland government tools. For example, NUNA GIS is the government of Greenland's primary GIS tool. They do have agreements with Esri. They use a variety of Esri products and spaces. There's not really kind of a Greenland repository yet. I'll touch on some of those coming up, but hopefully our work is helping with making the research accessible that is Greenland focused for people in Greenland to be working on. A brief on why QGIS. So it's accessible, it's free, it's open source. Most of the things that you can do in an ArcGIS that requires a proprietary paid license, you can do in QGIS. It's got a robust analysis tool, so you can come to it, you can just use it like a mapping space, or you can really dig into the analysis tools that exist there. It also has a wide user base, a lot of documentation for how to use it. So in that way, if tools like Quantarctica or Q Greenland can actually be used to help people learn simply about using GIS and software like QGIS. And it's ready to go as far as making your maps. And all of these skills, of course, are transferable to other things that you or students might be interested or need to use in GIS environment. So one of the things that one of my colleagues, Andy Barrett, often says is open science is kind science, which I think is a wonderful way to think about it. So that means, as I said, things like open development. So you can see what's happening as far as this production. You could leverage this code for creating a data environment or package for any other topic or place that you wanted to work on. We've really worked to have thorough and well organized documentation. We're actually in a little phase right now of doing some cleanup there to help people find their way around the development and the tools and the resources available to them. This is the kind of thing that is not a one and done, which is, of course, probably how we still like to arrive in these things in a lot of spaces we work, but is not being successfully kind in our science. And so another one of these things that we've been emphasizing are tutorials, updates, how-tos. So one example is this beginners tutorial series, which is a video tutorial series designed for people who have never used GIS software. It was really important to us that we're helping people who, hey, I want to learn about this, but really all of this is pretty brand new to me. They can get on board. And I think that just as a comment on sort of our scientific community, I think this is an area that really needs emphasis. We don't collectively, and there's improvements for us still to be made in Q Greenland, but I think we don't collectively always achieve a bar to help people use tools that we've built, starting from an expertise that might look pretty different from our own and our own, for example, technical expertise. So this is an area I just want to emphasize for thinking about collectively, and something that we've definitely put resources into in this project in a way that sometimes I know hasn't happened for other projects that I've led. Um, so part of that work of helping people see how to use this is supporting and also demonstrating diverse uses for folks. So providing examples and pathways for doing research and analysis, for working through using this space for presentations and publications, thinking about how people can interact with this for field planning or doing work directly in the field. What does it mean to use Q Greenland and its resources for supporting education and teaching? All of these sorts of elements help people to understand how this tool is going to be useful for them. And I really encourage other people who are like working in tool or a space that needs dissemination and uptake to be thinking pretty deeply about this. So we've had some success here in being able to provide something that's free, it's login free, it's supported, and it has this kind of pre-synthesized space for people to work in. So it can support a lot of uses. So we hear about people using it for presentations or publications, maybe using it to locate field sites, using base maps that are existing there, being able to use it while they're in the field and adding things readily and putting to use that offline capability that exists, and also being able to support researchers, educators, and again, helping people find data about Greenland for people located both outside of and inside Greenland, keeping in mind that there's a healthy Greenland-based research community of individuals and organizations. Um, so some of those kinds of things also look like trying to partner with other groups and projects so that Q Greenland is being used as a tool in these different spaces. So one of those examples is a curriculum called Polar Pass, which is a semester length amount of curriculum modules that use interactive environments and also Q Greenland and GIS for helping students meet some of the climate literacy and polar literacy requirements using this curriculum, which has been really fun to interact with the development of those modules and see them used in a variety of higher level undergraduate classrooms, be it use just to in classrooms that the emphasis is learning GIS, in others the emphasis is learning something about, you know, polar climate, and other places it might be Greenland specifically or glacial processes, etc. Another thing that was important and that we conducted towards the end of kind of our first period of development for Q Greenland was undertaking community user research. And I would give a shout out to the NSF's EarthCube program for having done a really nice job of supporting the projects involved for understanding community research and being able to undertake that and think about how to use that information. So some of the things that we were hearing from the community as we were wrapping up our first period of development, really to develop the Q Greenland package, was when it came to geospatial things, pros, people like open source, they like having visualizations, they want things to be user friendly, have good tutorials, be efficient to use, all of these things when the system's working well, and especially kind of an open source system is working well, you feel that there's other users, that there's support, that there's interaction, and that things are accessible. Now, some of these can just be the flip side of the coin on the con in instances where things feel not user friendly, where you might have to run into the use of expensive licensing. That you would have if you were like needing to undertake using this with an ArcGIS, for example. Sometimes people can be challenged with the learning curve. Things are confusing. How do I go about doing these? How do I maintain it? It doesn't seem complete, etc. So we took time just to hear from people on what they like most and also hear from users about their interests. This were items that they were really highlighting in regards to tutorials and documentation, those being really important for them to feel successful in using a tool. Also, information on how to collaborate and feeling that there are other people using it or people in the development who you can interact with, and hearing about use cases. How did someone else go about this? What other options are out there? And very critically, ways to work with more data. So, as we were developing Q Greenland and people on the research and education side, those are being our primary audiences. We're working with this. So often people are like, well, how do I add my data to this? Or how do I add this other data over here? Or what if I found this thing? Or how do I find more Greenland focused data? Because one of the things about Q Greenland, as I mentioned, it's not meant to be your primary data source, right? So even as you're working with data in that environment, that is going to point back to the original archived data that layer is coming from. You're going to be encouraged to go back to that original data source. If, for example, you need additional time periods covered, we sometimes might subset a data set so it's not as high a resolution, so you can see that it's there, but you're going to want to go back to that high resolution data if you're picking something up. Or, we're just giving you a sense that there's some work within a topical space, and that happens to be your primary interest, and you need to go find all of the dozens of data sets that are specifically on that topic, which of course is more than we're going to serve in a tool that is designed to give you something of an interdisciplinary base space for working with. But in this kind of ways to find more data, this is a lesson that we learned ourselves and users also learn as they're trying to bring data into the Q Greenland environment, is this can be really challenging. Um, all of us as a community have not over time put enough effort into making data that is nice to use data, that is kind science data. So there can be real challenges with the format of data. Sometimes there might be translation needed between actual languages, Danish and Greenlandic and English, or maybe just really a translation needed between the kind of cryptic information that someone put into their metadata that, what does variable ST_EX mean? And also maybe an incomplete picture with missing data, or maybe that metadata is really missing some key parts for you to understand what the contents of a data set is or how to use it. So this remains a challenge, as how do we make more data findable and usable? So in our next steps for Q Greenland, we wanted to do something to tackle some of these issues that we were coming upon and our user community was coming upon. And so enter Q Greenland Net, which is the current kind of work project underway. Part of the idea here was to move away from people depending on a QGreenland curated interdisciplinary data package. Now, I want to be clear that still exists. Probably later here in 2026, we'll be releasing a new version 4. You can go ahead and get version 4 alpha releases right now as we work towards that. But we also wanted more ways that people could self-curate data sets and data layers and move away from kind of a all-in-one to something that also has exploration space for you to go and find and share new data. So that's what's happened here in QGreenland Net. And this is now a partnership between the National Snow and Ice Data Center and the Center for Education, Engagement, and Evaluation that sit within Ceres at the University of Colorado, and a Arctic Data Center partnership for the Arctic Data Center that sits within NCES at UC Santa Barbara. And also pulling in DataONE, and I'll talk a little bit more about what DataONE is here in just a minute. So this group collectively kind of came up with our vision of open science as it pertains to and includes QGreenland. And we'll walk through the different portions of this detailed graphic. So I'm going to start here on the left side, where we're starting to think about federated data networks as a way to make more data findable and accessible. So here, enter DataONE, which is a federated data effort, and that means that DataONE is essentially pulling metadata from many different member repositories and making that metadata all searchable, findable within one place. So that means it can include specialist and generalist repositories. So specialist repositories often have like a topical or a geographic focus. Often the metadata at specialist repositories require more metadata categories. Maybe they're more particular about the format of those metadata. And then you have generalist repositories, which are often going to be more lightweight in their metadata, but they might be, fairly agnostic to topic or location or something like this. Then we have our repository federation. This is essentially, in this case, the DataONE that is pulling all of this metadata and information from across repositories and making it a new searchable index in something like DataONE or a Google dataset search or something like this. And they're really nice ways that federated data can help us out in first making things follow along with the FAIR, findable, accessible, interoperable, reusable principles, right? This is certainly making things more findable because I can go to one place to search dozens of different repositories. And perhaps, depending on how things are set up, it's going to be more accessible. And we'll get to some of the interoperable, reusable bits, which is not necessarily addressed just by federating your data. This is also helpful on those care, collective benefit, authority to control, responsibility, ethics, in part because you can make sure that data is archived at a repository that follows all of the things that you need out of your care requirements for a specific data set, and then those can kind of control what is going to your federated space. So data can essentially continue to sit itself in some designated primary desired location, which is really handy. So the first thing that working with DataONE has helped us for QGreenland is we had earlier set up an Arctic Data Center data portal. So and any groups and projects can set up a data portal at the Arctic Data Center. It helps you to be able to filter and display or reveal Arctic Data Center data related to your project. And so with our Arctic Data Center data portal, users could go there and they would find more than 600 data sets with Greenland location geospatial data. Well, that is quite a few, but it turns out there are literally tens of thousands of more Greenland-focused data sets out there. And so by transitioning to a data portal that is now hosted by DataONE, we are instead being able to filter and expose many more data sets. And this plot is giving you an idea of each of those on the x-axis is a repository. Don't sweat it if you can't read the details of those little letters. And then on the left side is a count of data sets that include Greenland geolocations within them. That could be a global data set, right? It's not necessarily going to be itself a Greenland-focused data set, but those locations are going to be included. And you can see something like Pangaea. I'm actually never sure how to pronounce that, but you can see that um, large general repository itself already has more than 50,000 data sets, including Greenland geolocations. But we also have some specific ones. We've been doing work to bring on Greenland specific or Greenland heavy repositories. So for example, GEM here, the Greenland Ecosystem Monitoring Program, was onboarded as a repository for DataONE maybe a couple years ago now, and you can see that they have a lot of data records. So by switching here to working in a federated data space, things are more findable. There's more topical diversity because you can pull in repositories, that cover a wide range, better data sovereignty for people to be able to decide where their data sits, but information about it is going to get out. And so it means that at this point, we're filtering, more than 50,000 data sets for users to be able to explore and look at. Now, that admittedly could be a pretty overwhelming amount of data, and we do still, I want to point this out because I think this is, important across a wide range of spaces, is there's still limited capacity to bring Greenland-focused data repositories on board to participate in DataONE. In the case of Greenland, there's also aspirations to develop Greenland-based data repositories. Those don't exist yet. And so there can be a little bit of a, cart, horse, egg, chicken, these sorts of things as we develop out data access. But the nice thing is that having something like this can inform the development of new repositories so that they're going to choose already a metadata scheme that is going to play well with others and, for example, be readable by the DataONE systems. And then we now have a DataONE data portal. This is already up and online, but it is in development. So expect improvements to continue during 2026. But here you can already be searching and filtering and playing around with these tens of thousands of Greenland-focused data sets. And the DataONE data portal is also been introducing a data visualization platform to be able to get a closer look at different data sets before you're understanding, do I actually want this data set, or I want to subset it, or what's available out there. And we're still working on how we'll utilize this visualization space and making that user friendly. So it's available for exploration now, but there's not a lot of content here in this data visualization space yet. One of the challenges in this, I don't expect this to be a sort of solved something, but is always thinking about what development is prioritized so we can meet different use cases. What are we going to prioritize to make sure that people can download it and they're going to have it locally and be able to use it in the middle of nowhere in the field where you're not wanting to use up any internet bandwidth. Other people really want things that are all going to work well in a cloud computing space at this point, et cetera, et cetera. So that's a kind of constant conversation in regards to developing a download package versus developing something where you can explore things online, et cetera. All right, next portion of this open science vision. So on the left, I'm giving you an idea that part of our open science vision is that people can more easily find data sets because that information is being collected and made easy to work with. Another thing that I had mentioned is we're having challenges, and users often find challenges with transforming their data into something that is going to be usable with other data sets. So um, like tiling, mosaicing, kind of this sort of data harmonization aspect. And so what we wanted to do was undertake building some kind of basic recipes or workflows that undertake or make a little more simple often needed data transformations. And so that's this open geospatial data cloud, essentially a suite of data recipes or workflows that live at and are hosted at the Arctic Data Center. Sustainability is always a big challenge for open science projects. I can't tell you how much this came up in our conversation for the Geosciences Open Science Ecosystem meeting last week, but sustainability is a toughie. And one of the things that we did to try to help is, in this case, hosting tools at the Arctic Data Center, which hopefully has kind of a more robust longevity and also is able to support a lot of users. So that the things that we're developing here in the Open Geospatial Data Cloud and those tools are going to be usable by people with a wide variety of different data, whether it's Greenland focused or not. So the way that this kind of works as the combination here of DataONE and the Open Geospatial Data Cloud up here is you have member repositories. For DataONE, they're best to be using schema.org, as this is like the standards for your metadata. They feed into DataONE, where they undergo also assessments for what's the quality of your metadata. Are you doing, kind of key things in order for people to be able to use your data? Then it's going to be accessible here in DataONE. And a person could be a data user rather than a data producer, and you could pull data that is archived in DataONE. You could use these geospatial harmonization tools to undertake some transformations to that data. It might have something to do with subsetting or projection or gridding or any kind of number of things. And then there's the possibility to go ahead and take that new data product and archive it back as a new addition to a member repository, so that the derived data set you've created is now also available for others to use within this DataONE ecosystem. So hopefully creating kind of a feedback loop so that data producers need not, I mean, best if they're the ones who are making their data very friendly and usable. But if they didn't, or perhaps that PI doesn't exist in science anymore or in a living life form, someone else can come along and make those data more usable and essentially share it back for the community to use. And that's sort of this illustrated part here, where you're then taking your geospatial data sets and they're then feeding back into creating a data environment that you download, like QGreenland, or being accessible on data portals like the DataONE portals, etc. Okay, so I'm just going to spend a bit of time kind of outlining some questions to grapple with, and also some opportunity spaces. And this is actually going to be the last stuff that I'm going to talk about. I kind of wanted to leave a good amount of time for Q&A, because I think there's a lot of interesting activity happening within the open science, geoscience space. And also, like I said, I was just at this meeting, and there might be some interesting things there we wanted to discuss that I wasn't making into my slides as I was preparing them last week. So Some questions for us to grapple with as a community. One of those, of course, is who is responsible to do the work. So, who needs to be the one following data or metadata standards? How much responsibility is there on a lead PI, on the actual person, collecting the data at the point of collection? Maybe they're a grad student in the field. Is this something that we lean on repositories for checking and making sure that that happens, et cetera? What about usable file formats? Is it okay to provide one? Do you need to provide many? What kind of uses do you need to anticipate? Is it okay just to serve the uses of your project, or do you need to imagine the other spaces that your data may be usable now or in the future? Modernizing past data sets. This is something that we're hoping that this Open Geospatial Data Cloud kind of circle around can assist with a little bit as you're finding a past data set and undertaking the work to modernize it yourself. There's maybe a pathway for you to be sharing that back out. But there's so much. I was just actually hearing some very wild statistics about, how many data sets and papers are accessible and understandable to AI, and it's a pretty miserable number. And in a time now when AI has so much emphasis in being able to understand and think about integrating it with our research processes, this is a real issue. And also maintaining tool functionality. What does it mean when a piece of software you depend on has an update and then you need to change your code? What does it mean when an operating system has an update? How do we make tools that may have financial support for their development? What does that mean to pull that in towards the future and maintain tool functionality for the future? I think we've sometimes looked towards like a community approach to this, where, hey, we're going to create like a community that's open. Maybe they're hanging out in GitHub discussion spaces or et cetera, and sort of depend on community expertise to do this. I have found within QGreenland that's not realistic. And so I think we really have to think as a community about how to do this better. And we haven't come up with a good solution at this point. And that relates to this sustainability part. Um, and what pathways are realistic and whether kind of community sustainment might be a bit of a myth. Or maybe there's a kind of a user base has to surpass a certain threshold amount, which could be really hard for your niche topics, or geographies or things like that. And I think another really important question that we see coming up is also how open science interacts with care principles. So when we think about things related to data sovereignty, where a data set might have more guidelines, it might specifically not be a machine readable data set. It might require, certain logins or applications, or there might be very important limits on who can view and access a thing. And how do we start to integrate some of those sorts of elements into what we do? Which is just a side note that I had a really interesting conversation a good while ago with someone who specializes in Web3 and thought that there might be some really interesting sort of ways to essentially tag data with requirements that could help with this space. But I haven't seen any progress in this other than that really interesting conversation a bit ago. So, opportunities that are related also to these questions for us to grapple with is one thing that I think came out really clearly from the Geosciences Open Science Ecosystem meeting is how nicely AI readiness Venn diagrams with open science. So, things like machine accessible, machine readable, excellent documentation, ready for easy transformation. So I think in many ways, even if you might not be tackling AI space yourself, that be starting with a focus on open science practices and open science activities. Sorry, I'm bouncing around. I have a cat on my desk over here who's wiggling. Um, that those two kind of tackling these things together, I think could be a really valuable way for our geoscience community to think about data practices that are prioritized within this administration and by our federal government at this time too. One thing too is that I think by working on generalizing capabilities, we're going to get better and better at supporting both our niche topics and our kind of big ones. So something that has been on our mind is, what development can we undertake with our code so that it's going to be more ready to support people who want to create a XYZ environment using data or topics of their own interest. And so, how do we generalize some of these resources and provide, again, the tutorials, the documentations, the to really step people through being able to undertake this? I mean, QGreenland has been developed by professional software developers at the National Snow and Ice Data Center. That's not something that is probably replicable, over and over again for all the places and ways that we would like to have geospatial data environments. And again, thinking about serving a wide range of user skills and having a community that does that. And I do think, undertaking some of this work practices of open science where people can see what development is happening, where people are creating a work ethos that kind of invites more open question asking, admitting of where things are challenging, saying, hey, I need help. This is something that I don't think scientists are great at. I think it's easy to shy away from asking help or admitting you don't know how to do a thing. But I think open science really encourages us to do that. And I think it's going to be better for being able to serve diverse users over time and also get more people on board, especially at a time right now when we're kind of hemorrhaging a lot of expertise. How can we set things up so that as expertise kind of has ups and downs, we have tools in place so that when we're needing to build up expertise again, it's going to be possible for people to do that. So thanks. That was all of the items I wanted to share today. And I really look forward to any questions and also just conversation or comments on some of the things brought up here. So thanks so much.
Thanks, Dr. Moon. So if anybody has any questions or comments, I'm going to ask you to use the raising hand feature or type your question in the chat and I can cue you. Thomas, you are unmuted. I don't know if that's to ask a question or if that's an accident. Oh, never mind. Or comments as well. Oh, there you go. Oh, hi, Shanae. Shanae, please go ahead.
Hi there. Hi, Twila. How's it going? This was such a nice presentation. Thank you so much. I'm just curious about sort of sustainability, this comment that you made at the very end, and whether it's a myth. I've worried about that myself. I think maybe getting to the middle of your career, you think, okay, I'm already feeling like I can't sustain my whole part in this ecosystem. How sustainable is the work I'm doing? But taking it to a broader, in terms of the sustainability of these data, really critical data sets, have you had interesting conversations or useful conversations from the federal funding perspective on that front? So moving outside of these kind of 3-year ad hoc kind of proposals that we tend to submit to NSF or NASA or NOAA, to something more long term to properly curate these data? That would be one question. And then a second question, just out of interest, with this interest, kind of renewed interest in Greenland in particular, here on the federal side, is there have people approached you about that, or is there an interest, sort of a renewed interest from the federal agencies, given the kind of renewed focus the administration has on Greenland in particular and in the Arctic? So sort of two questions.
Yeah. Well, the second first, I haven't heard anything in particular. Like I haven't, been contacted by the federal government to say something about, Greenland specific things related to their interests. I'm not inviting perhaps either. So I couldn't say whether, some of these tools are being used in different or new places, but it's not something that, is obvious or apparent to me. We continue to focus on our number one audience being geoscience researchers, and number two audience being educators, and then doing our best to serve other audiences as we can, and also especially doing our best to really meet kind of needs and requests that come from Greenland and also a Danish organization. So our coordinating board, then Vinton Valentine chairs, has representatives from OSIOC and the Greenland Institute of Natural Resources, and DMI, and DTU, et cetera. So trying to make sure that we're kind of integrating well with these systems, or pulling in data that they think should be prioritized, and also making sure that doing our best to do development and things that can be helpful to other efforts like NUNA GIS and Nature Map, which are Government of Greenland efforts. Okay, first question, and I'm not sure that I kind of properly summarize that, but really kind of on the sustainability and the like sustaining data sets, and tools. And first off, I have been reflecting a little bit on, tools are not necessarily meant to be sustained forever, right? Like other technologies and other software is going to come along, and eventually you're going to want to transfer XYZ tool to some other platform or functionality or something like this. But data is something that we really want sustainment. And that's something where I do think kind of the effort to at least kind of those steps of modernizing data are really valuable, because at some point you get too far from the original and it becomes like almost impossible for someone to understand what was done, or be able to work with it. Um, I did hear an interesting talk from at the PI meeting from Chris Markham, who's now does some advising with the Data Foundation, and he had just completed a report for them that was showing that maybe fewer data sets than kind of like this initial panic would suggest have been disappeared, but but many of those data sets might not be fully gone, but their access to them has been removed, so that they might like sit on a government server, but the way that you were to interact and retrieve them from that server has been put at risk or removed. um, and I'm not quite sure yet what to do with this information, that maybe data is not disappeared to the extent that people are concerned, or maybe that data doesn't need saving quite to the extent that kind of headlines meant. But at the same time, if we can't access them, it's kind of roughly the same as disappeared. I don't know how that gets built up in the future. And I have, I don't think that there's still, like, I don't hear a lot from NSF or NASA on sustainment of tools or sustain. I mean,
Yeah.
that it continues to be a request, and I continue not to hear very enlightened ideas coming
I,
from the
right.
agencies.
I don't think that I agree with you. I don't think the ideas they're few and far between, and they're not very enlightened. And I see you in particular, not to put all the pressure on your shoulders, but your leadership on this is so important, for that exact reason, to show people what the vision could be, and what the possibilities are there. I think from, the bottom line at the moment, we can't talk about climate change and climate research in our proposals, but ultimately that is what we require these long-term data sets for. And being able to access these older data sets, or these data sets that suddenly have kind of gone offline a little bit, is really critical. And for the future, to really understand like what environmental changes have been happening over the past 20, 30 years, beyond just looking at, the reanalysis data sets, which are really commonly used in academic research. I'm thinking more of these, in situ measurements, or specific projects that occurred over time. So yeah, I mean, I guess all I'm saying is great. Thank you so much for being there to lead the charge on this, because it's extremely important. And it is frustrating to be told, I think personally, to be told, that we're obliged to generate open science as part of our research proposals, but then there's no funding provided to sustain that, right? So you put it
Yeah.
into, as you said, one of these DataONE repositories, you put your data over there in Pangea or in Zenodo, and then that's it. It's there, it's done. You don't have funding to interact with the end user who may want that data, in a slightly different format, or they might want up-to-date information or whatever. We're constantly like, well, we don't have funds to provide support to you, as an individual PI. So I think
Yeah.
sorry, I've taken up a load of time talking. It's a complex topic. But it does require vision, and it does require a rethink on how some of this is funded, for sure. I think.
And I think too, to the extent, that all of us can be, letting our NSF program officers, letting leadership know that we use resources, I mean, it really hurts my heart for the Arctic Data Center to not have funding certainty when we look to them to be a strong and lasting data repository, but so the best we can do to really emphasize that these are valuable and used, and be able to depend on these kind of, bigger umbrellas or foundational organizations, is really a challenge right now. And I think, I'm hopeful that there are some paths where the squeaky wheel gets the oil. But, I also understand people's concerns about who you squeak to, and whether it gets, doesn't get any oil at all if you squeak in the wrong places. So this is a big challenge, and I think it's unfortunately going to continue to be so. Yeah. I do see that there's a cat tax request. So sorry, you're all gonna make a little bit of seasickness. Um, Here's my wiggly cat. She's giving us all the back. She doesn't want anything to do with too much chatting around here.
She's a sweetheart. I can just tell just her sassy expression. So there is a question. So there's one person in the chat. If you have a couple more minutes, looking for examples of publications on long-term trends of rocky intertidal biology, citing use of Greenland.
Um, I love this request. I don't have an idea about rocky intertidal biology citations, but I would suggest you go to qgreenland.org, click on more data, go to that data portal, and stick in intertidal, stick in biology, and see if in that I think, more than 65,000 data references at this point. You can find some that include intertidal biology, rocky intertidal biology, or maybe someone else here knows something about this, and they should put into the chat to help Alan.
Cool. I also just dropped the link if you guys all just want to explore. And then Annie has two questions. What would be the expectation for curating and updating the project as AI is used? And then her second question, how is cybersecurity considered for the software and content?
Yeah, for curating, updating as AI is used, we haven't gotten, I'd say, too much into that space because we haven't really introduced AI as a tool yet in our work for building QGreenland as a data package or in our work for how the Open Geospatial Data Cloud recipes work. So I think that that's actually still a pretty open question in regards to curating and updating. And this is the kind of thing too, where I hope that as we are in the future able to make some advances in generalizing the code for building a geospatial data package, that's something that you might just go ahead and branch off in your entirely own space of making your custom GIS package space and integrate AI produced or AI cleaned up or any sort of things that you might want to do, sort of leveraging out of a more generalized code. But mostly open conversation space there. Cybersecurity, this is an interesting one. We're actually like right now doing some updates related to cybersecurity on the QGreenland side at the University of Colorado. And then also cybersecurity has created some slowdowns for us. We were hoping for the Open Geospatial Data Cloud recipes to be able to be like exposed and usable for people outside of the Arctic Data Center more easily. And cybersecurity issues have been slowing that down a bit. And so we may have to kind of take a temporary step of having those be usable at the Arctic Data Center and perhaps kind of like requestable for use or actions from people outside. So those are real issues, probably without perfect answers.
Thanks, Dr.
Thanks,
Moon.
Annie.
Thanks. So that is my my cue, and we are at 3. Does anyone have any last minute questions while we still have Dr. Moon with us here?
Yeah, and feel free to send an email, give a call, check out things on GitHub and comment there, and be in touch.
Great. Well, with that, I think we can conclude today's seminar. Let's all thank Dr. Moon one more time, and thank you everyone for being here as well. Our seminar series, as John said at the beginning, we have one more left of the semester. That's next week, same time. Actually, not same time. It's at noon instead of 2 p.m. and it's in person. So thank you, everybody. Have a wonderful afternoon.